Hi, good afternoon, everyone. Welcome to our patent strategy seminar. This is the fifth in our sixth series. Today, we are going to talk about NVIDIA, and we are going to focus on some of the key patents filed by NVIDIA. And because this topic is very technical, many of their patents involve very complicated technical details. I have to involve two of my colleagues, Mr. Kui and also Mr. Ong, to help to explain some of the patents. So let me start by just a short introduction about myself. I'm a patent attorney for the past 20 years. I'm active in Singapore, Malaysia, and the ASEAN region on the IP protection and the monetization work. I would like to start by doing a general overview about NVIDIA. As you all know, NVIDIA is an American company based in California. It is led by its visionary CEO, Mr. Jensen Huang. It is a company listed in the NASDAQ, US Stock Exchange. And NVIDIA, as you all know, is a company that specializes in graphic processing cards, or GPU. And its GPU is used for various applications like gaming, professional visualization, cryptocurrency mining, data centers, autonomous vehicles, and also artificial intelligence, and many other future computationally intensive applications. What NVIDIA has is NVIDIA adopts a platform strategy. So what NVIDIA brings to the market is not this GPU card only. It brings with it, together with the GPU, it also brings to the table the CUDA software architect, and also libraries of software stacks that build on the CUDA. And together, they provide a system-on-a-chip solution for different vertical markets that they serve. Okay, so what are the revenues of NVIDIA? NVIDIA, 87% of the company's revenue comes from the sales of GPU, and it is the undisputed market leader in the GPU section of the chip market, where it holds more than 80% of the market shares. The gaming has provided the initial demand for GPU, but NVIDIA moved beyond gaming. New industries like self-driving car, cloud computing, metaverse, artificial intelligence. NVIDIA also adapted its GPUs to serve these new applications. And the other way NVIDIA makes money is through licensing of its intellectual property rights. NVIDIA is the market leaders in graphic cards. It holds over 500 key graphic cards patents. And the closest key patent holders, Intel, has less than 200 graphic cards patents. So the NVIDIA GPU technology and its patents are highly sought after by different companies in different industries. And in 2016, Intel has agreed to pay $1.5 billion for 5 years, or $300 million a year to NVIDIA, so that Intel has freedom to design using some of the NVIDIA's patents, graphics patents, without worrying about infringing the NVIDIA's patents. So this is a very important thing in the world of technology, a concept called freedom to operate. If you want to do anything, you have to make sure that you have the right to use or to do something. If a technology is already patented, then there will be no freedom to operate, and you will need to license the technology in order to do the technology. So this is another way where NVIDIA makes its money. So today we are going to talk about patent strategy. And when we talk about when you explore what is the NVIDIA generic strategy, patent strategy, we probably have to look at Professor Michael Porter generic strategies model, and to study, to analyze the case of NVIDIA. So according to Professor Porter, a company can be competitive, can have sustainable competitive advantage by following either one of these three options. One is you choose to be a cost leader, offer no frill, everything the cheapest, no extras, and you can compete because you are the cheapest. An example of cost leadership is, for example, IKEA or Amazon, right? You can buy the cheapest from IKEA or Amazon. The other way you compete is to differentiate, come up with something very uniquely desirable, and you target on a particular niche market. And this is, to me, very true. You cannot be stuck in the middle. If you are stuck in the middle, you are everything to everyone, then you will end up being a very mediocre player, right? You either have to choose to be a cost leader or you become a differentiator. So in the case of NVIDIA, NVIDIA is a perfect example of a differentiated focuser. It has a very differentiated service, differentiated offering, and it targets specific market. But what is unique in NVIDIA is it has something that you can differentiate and target different markets in a very short period of time. And we have seen, like, NVIDIA has moved from a graphic card user to become a leader in so many industries because of this special combination that they have. NVIDIA is able to satisfy the special needs of its various vertical market through its combination of its GPU and its software stack, which is built on its CUDA. So let me explain a little bit about the NVIDIA CPU and also the CUDA. And my colleague, Ong and Kui, will focus on some of the patents that NVIDIA has filed for the GPU and also for the CUDA system later on. So what NVIDIA GPU can do is it can do parallel. The GPU can run parallel processing, meaning it is able to do computational intensive processing concurrently in its many cores. In one GPU, there are multiple thousands of cores, and each core can concurrently run this computational intensive task. This is different from CPU, where you do the processing serially, but GPU can do it concurrently. So this makes GPU highly desirable for computerly intensive tasks. And another unique feature about NVIDIA GPU is it is programmable. They have built a CUDA infrastructure which serves as a middleware or a application programming interface API, where the programmer can program the GPU for different applications. The programmer can exploit the parallelism of the GPU for multiple processing, and this makes NVIDIA solution very powerful. So what NVIDIA does is NVIDIA charge a high premium for its GPU. It has designed different GPU for different applications, and it allows people to use its CUDA programming for free. Yeah, it is a closed system. So the NVIDIA platform strategy has three key components. The first component is it has a CUDA programming language. It has a group of highly skilled programmers who are able to program the GPU using and NVIDIA has invested heavily in educating the developer using the GPU. And NVIDIA engineers also design highly specialized GPU hardware, and it outsourced its manufacturing, the capital-intensive manufacturing, to third-party players like TSMC, right? So they don't invest on building the plant. They outsource the manufacturing to TSMC. And what is important is you have a lot of industrial users who increasingly need fast computing. Like we can see from the graphic card, NVIDIA did very well during the crypto mining, right? Crypto mining require very mathematically intensive operation to calculate the coins, the crypto mining. And NVIDIA was able to go in by using its chip and using its CUDA software to design some chip in a system in a chip solution for crypto mining. And when Metaverse came, again, Metaverse, you require a lot of computing work to project the images, you know, to react in an avatar in a Metaverse universe. So again, this computerly intensive can be performed using the specialized GPU of NVIDIA and the software to program for those applications. And when you have cloud funding, we have this the various cloud hosting companies like Amazon. Again, NVIDIA came into the picture. NVIDIA was quick to seize the opportunity because cloud funding also require a lot of computing activities happening at the same time, and GPU seems to be able to adapt to that. And using the CUDA software, you can program the CPU for that application. And now you have autonomous driving. Again, autonomous driving, you need to take a lot of data, you need to process data, you need to use AI to learn. In the split of a second, you have to decide how the car should react. And that computerly intensive work can be done by CPU, and you have the programming CUDA software to do programming for the application. And now is the generative AI, where you have a lot of model that you need to train, the AI model that you need to train, and what the GPU can do and the CUDA can do. Again, very quickly they can adapt and they can become a market leader in all this emerging technology. And this is something that is very, very impressive. So this is what NVIDIA has done. NVIDIA has moved from a chip company selling graphic card to a computer platform company selling a ready-made system on a chip solution, right? And this system on a chip solution combines the very specialized hardware with the CUDA programming, and you can offer to the market quickly. It has a fast rollout cycle, and when there's a new emerging opportunity, NVIDIA sees it quickly and move into it quickly with that solution, with the CUDA program, with the CPU, and it quickly gained a first mover advantage, meaning you are the first to come up with a solution. And when you are the first mover, people use your system first, then you have the switching cost. It's difficult to switch because you invest already in that system. To move out will be difficult. So because of that, you can command higher pricing power, and because of that, you make higher margin. And you look at a hardware company like NVIDIA, it has 65% gross margin, which is higher than that of Apple computer, right? We all thought that Apple can, should be the most differentiated handphone, right? But NVIDIA selling hardware can make more than 65%. This is more than a software margin. So this is the competitive advantage of NVIDIA. So Warren Buffett has populated the concept of economic mode, right? According to Warren Buffett, he wouldn't invest in any company without economic mode. Meaning, what is economic mode? Economic mode meaning you have a barrier of entry, people cannot come in. you can continue to make money using that competitive source of competitive advantage. So NVIDIA's enviable economic mode lies in the patent or IP protected proprietary chipset, the GPUs, and also the CUDA system for its targeted market. So today's presentation, there are many competitive advantage. We are going to focus on patents, and my two colleagues and me are going to look at some of the key patents that enable NVIDIA to create a competitive moat. So before I move on, I think it is good for me to very quickly talk about some of the IP, right? Because today's topic is on intellectual property, some of the common IP that everybody should know if you have not known it. So when we talk about IP, we look at patents that protect new technology, copyrights that protect the original work like the programming code, trademark that protects the brand like NVIDIA, the design that protects the outlook, and also the trade secrets that protect proprietary technologies. All these IPs are intangible assets. It gives the owner a monopoly over your ideas. It is limited by jurisdiction, and they are limited by time. So to maintain, you need to renew all these IPs. And for NVIDIA, IP is the main engine of growth, right? So when NVIDIA see anything that you can solve using mathematical calculation, this doesn't matter how complicated, how complex, NVIDIA will come up with a way to calculate, come up with a process to calculate it and program that using CUDA into its GPU. And it designs its GPU to be better and faster and smaller so that it can handle more complicated tasks. That's what NVIDIA has done. And all the ideas by NVIDIA, they are protected by patents. The source code are protected by copyright. The brands are protected by trademark. So these are how NVIDIA protects its idea and own those valuable ideas. So in order to own an idea, right, your idea to be patentable, your idea has to be new, meaning a new combination of steps or new combination of elements. They have to be inventive, meaning they solve a problem, they have a technical effect, and they are useful, meaning they has to be implementable, right? These are the three criteria to get a patent. And in some of the patents that we share, you will see that NVIDIA's invention comprises of combination of steps that solve a problem, and they can be carried out in real life. And these are the few categories of patents that you can protect. It can be an article patent, like POSIT tag, where it involves a combination of paper and glue. It can be a machine patent, like for photocopying machine, where it involves a combination of moving parts. It can be a process patent, like a manufacturing process of packing milk in a Tetra Pak patent, or it can be a composition patent, like in a drugs patent owned by Pfizer. Today, in the examples that we quote, you will see how NVIDIA has combined different steps together, different mathematical calculation together into a flow, and they use that flow, they code the flow and put it into the CUDA, using the CUDA platform into the GPU to perform those tasks. Okay, and when you come to $1 billion market, right, you don't use one patent. You need a portfolio of patents. So NVIDIA is following this patent ticketing strategy, where you have a portfolio of patents to protect technology. So then when they come up with a chipset, when they come up a new platform, a chip in a system in a chip platform, they will file a portfolio of patents to protect the idea, so that when there's any competitors, you can go after the competitors with multiple patents. So a little bit of statistics. NVIDIA has filed more than 10,000 patents globally, coming from 5,000 patent families. Right, this is the size of the NVIDIA patent portfolio. And the patent trend, you can see that NVIDIA has been actively filing patents over the years, and most of the patents are filed in its key market like US, China, Germany, Taiwan, and Europe. Yeah, so and these are the portfolio of NVIDIA. NVIDIA has filed patents in different area of technology, but most of their patents are found in the area of graphic processing. And we are going to explore in this seminar some of the notable patents related to its key technological breakthrough. Yeah, and our team has done research and has found some of the key patents found by NVIDIA, and we have compiled them into a handbook which you can scan and download for your reading pleasure. Because today's time is too short for us to go too deep, so probably you want to download them and you can study them on your own. So these are the key technological milestones by NVIDIA over the years, and some of the key patents protecting this key milestone from the transform and lights engine to deep DLLS chips, right? So these technically complex topics will be covered by my learned colleagues who are engineers by training, and they will be in a better position to explain the technology to you. So I pass the baton over to my colleague, Kui, to continue the discussion.
Okay, good afternoon, everyone. My name is Mr. Kui, and today me and Mr. Ong would like to share with you all some of the key patents found by NVIDIA which relate to their technological milestones. So the first key technology that we would like to inform will be the transfer and lighting engine. So the transfer and lighting engine is basically one of NVIDIA's earliest breakthrough technology, which was implemented in their one of the earlier chips, the NVIDIA 256. So in this chip, NVIDIA has basically managed to put or implement the transform, lighting, and triangulation processes into the GPU. So as you can see in this timeline over here, in previous years, usually CPUs are the ones that is usually performing graphical operations such as the transform, lighting, and the triangle processors. But over the years, we can see that some of these computationally intensive processors are gradually offloaded to the graphics processing unit. But the transfer and lighting still remain challenged to be implemented, but not until the 1999 when NVIDIA released this NVIDIA 256. So basically, with this, NVIDIA has managed to create a chip that offloads all of these computationally intensive processors that relates to computer-generated images and rendering to the GPU chip, so that the CPU, so that load from the CPU can be offloaded. So basically, this framework basically defines what future GPUs do. Because as you know today, there is a key differentiation in tasks by the CPU and the GPU these days, whereby the CPU performs those more generalized tasks, while the GPU computes the more computationally complex tasks. So with this NVIDIA 256, NVIDIA have managed to provide a chip that outperform most of its contemporary rivals at that time, such as the Voodoo chip by 3DFX, and also this has secured a very secure position in the market from there on. So I will now share the key patent that relates to this technology. So the key patent that relates to this technology is shown over here, titled Transform Lighting and Rasterization System, embodied on a single semiconductor platform. So, and this patent was filed in 1999, which is the same year where the NVIDIA 256 was introduced to the market. So over here in this patent, the independent claim, or the claim 1 of this patent, relates to a graphics pipeline system for graphics processing comprising the following modules, all on a single semiconductor platform. So all of these modules include a transform module. We receive geometrical information and transform into an object space, or from the object space to a screen space, a lighting module that performs lighting operations on the transform vertex data, and finally rasterizers that renders the transform vertex data. So shown over here in figure 1a is a figure from the patent that relates to that process flow. And with this, the NVIDIA 256 have basically managed to offload these three, the transform module, lighting module, and rasterizer module onto the GPU, so that the parallel processing of the GPU can be leveraged on, so that a more realistic and faster rendering of images, computer-generated images can be done. So with this, I'll move on to the next technological breakthrough by NVIDIA, which is programmable pixel shaders. So programmable pixel shaders was introduced in the third generation NVIDIA GPUs, which is the GeForce 3 series or the NV20. So programmable pixel shaders basically relate to rasterization, whereby rasterization is conversion of computer-generated geometry into pixels. So with this programmable pixel shaders, NVIDIA has enabled these pixels to be rendered in a more realistic manner. So as you can see in these diagrams over here, the programmable pixel shader basically allows for multiple texture maps for a computer-generated object to be rendered in a single pass. So over here you can see a height texture map and a bump texture map getting added together to form a final surface that has reflection. And furthermore, programmable pixel shaders further enable developers or programmers to create stylized shadings for their computer-generated objects. And furthermore, it also enables computer-generated images that has reflectiveness and roughness of bumps to be rendered in a realistic manner. So the key patent that relates to programmable pixel shaders will be this patent over here, titled Programmable Pixel Shading Architecture, filed on 19 June 2001. So in this patent, this patent basically outlines the architecture that relates to programmable pixel shaders, which is a system for processing pixel data on the graphics pipeline comprising a triangle module, a shader core module, a texture module, a shader backend module, and a combiner module. So basically all of this, what these modules do is to basically try to get the computer geometry from a computer generated object, apply shaders, textures, and color to that geometry, and finally combine all of this to finally form a realistic image, rendered image with surface roughness and reflectivity. So with all of this, with this architecture, pixel architecture, NVIDIA basically enables and furthermore with NVIDIA's parallel processing, this NVIDIA's graphics processing unit basically enable all of these pixels to go through this pixel architecture to finally generate a final rendered image. And with that, I'll move on to the next technological breakthrough, which relates to CUDA and Tensor cores, or more specifically, parallel processing. So over here, you can see a simplified platform of the simplified NVIDIA platform, which involves a GPU and the NVIDIA CUDA. So the NVIDIA CUDA, to put it in simple terms, it is something like intermediary between a developer or program with NVIDIA's GPU. So basically, the programmer can just communicate with the GPU through CUDA by using common programming languages such as C++. So basically, when the CUDA communicates with the GPU further is comprised of multiple cores. And these cores are basically what NVIDIA calls the CUDA cores or Tensor cores, which are specialized processors that perform specific mathematical operations such as multiply add operations. So a key patent that relates to NVIDIA's parallel processing technology would be this patent over here, titled Parallel Data Processing Systems and Methods using cooperative thread arrays and thread identifier values to determine processing behavior. So, which was filed in December 2005. So this flow over here is basically relates to how CUDA communicates with the cores on NVIDIA's GPUs. So over here, claim one of this patent basically states a method for processing data. The data comprising the method comprising defining a thread array in a processor, basically defining multiple threads in a processor. These threads will run the same program or different parts of an input data set. And the next step will involve assigning each of these threads with a unique ID value that determines the subset of the input data processed by the threads, and finally executing the threads, these threads in parallel and in a concurrent manner with each other. And during these threads, each thread will compute at least one program-specific function based on the ID values. So basically, this flow here, to put it in simple terms, this flow here basically defines that the CPU, the cores of the GPU is to receive a big chunk of data, which is subdivided into multiple threads, and these threads will be all sent to be processed concurrently by the processor. So over here, and with this technology, NVIDIA has basically managed to secure the market with management for parallel management on parallel processing. So with that, I'll pass on the next patents to my colleague, Mr. Ong.
Yeah, thank you, Mr. Kui. Good afternoon to all audience. I'm Mr. Ong. I will talk about NVIDIA's ray tracing and deep learning supersampling. Some of you may be familiar with the term NVIDIA RTX, which stands for Ray Tracing Tensor Extreme. It is the NVIDIA's technology that enables real-time ray tracing to simulate how light and shadow work in real world, such as reflection in water, realistic shadow, and stunning lighting effects. Here is a comparison between an image produced without ray tracing on the left and an image produced with ray tracing on the right from NVIDIA's website. The differences in shadow and lighting effect are very notable. Ray tracing is a computationally intensive technique which requires high parallel processing capability. The major steps involved in ray tracing include generating the rays between an observation point and the surface, determining the intersection point between the surface and the ray, collecting information about the intersection point, such as material properties. For example, whether the surface is transparent or reflective. And further processing this information by factoring reflection, refraction, shading, illumination, and recursive ray to determine a final pixel color. Conventionally, ray tracing is not possible to be performed in real time, and it typically takes hours to days or even weeks to render a single image. So NVIDIA's RTX enables ray tracing in real time. Here is one of the earlier patents related to ray tracing filed by NVIDIA in 2006. It is about real-time position ray tracing. The patent aims to solve the intersection problem during ray tracing. As mentioned previously, one of the first steps in ray tracing is to determine the intersection point. This intersection point is very important because later on, a secondary ray will be generated from the intersection point to a light source in order to determine a final pixel color. However, when calculating the intersection point, the actual intersection point may deviate from the calculated intersection point may deviate from the actual intersection point. For example, in this patent drawing here, the actual intersection point is on the surface, but the calculated intersection point is behind the surface. Consequently, instead of rendering an image that indicates the light is in front of the surface, it becomes an image that indicates the light is behind the surface. So this creates an imaging error. To solve the intersection problem, in the ray tracing methodology claimed by NVIDIA, at least one ray is shot from the pixel or from the observation point to the surface. Then it performs a series of calculations to determine the intersection point based on something they call it bounding volume hierarchies. The calculation further includes a few steps, including defining, utilizing, and recursively and adaptively refining an axis-aligned bounding box to locate the intersection point nearest to the origin of the ray, and continuing the refinement of the axis-aligned bounding box until a predetermined termination criterion is met. It is basically a series of iterations to improve the reliability of the calculated intersection point. And in an image, there are a lot of pixels, and each of these pixels will be subjected to the same process, which is why the parallel processing capability is essential for this application. Therefore, by utilizing the parallel processing capability of GPU, the complex computations during ray tracing can be performed simultaneously in a parallel manner. Next is NVIDIA's DLSS, which stands for Deep Learning Supercenter. It is a real-time image enhancement and upscaling using AI and machine learning to produce an image that looks like a higher resolution image. Each frame is rendered at a lower resolution and subsequently upscaled to a higher resolution. DLSS enables games to be rendered at a higher frames per second while maintaining high image quality. So, for example, in the comparison here, with DLSS, the FPS increased by almost 3 times while appearing to be a higher resolution image. Here is a patent related to DLSS filed by NVIDIA in 2021. It is about a video upsampling using one or more neural networks. The patent aims to solve the resolution problem when displaying a video stream. So video frames generated by a GPU or received from a video hosting site have a default or a field resolution. These resolutions may be less than the native resolutions of the display, such as the monitor or the phone. And this may cause the video frames to be stretched or only display at a portion of the display. So to solve this resolution problem, NVIDIA claimed a graphic processor, which includes a logic. The logic performs 2 major functions. The first is to receive a low-resolution video frame, including a low-resolution image. And the second function is to upsample the low-resolution image to generate a higher-resolution image using a neural network. The neural network is trained using a pair of images, including an image to be upsampled and an image with a higher resolution. So, for example, in the patent's drawing on the bottom left corner, on the right side is the input image with a lower resolution, 202. And the bottom one is the higher resolution image, 206. These 2 images will be sent to the neural network to train the neural network in order to output a higher resolution image on the right, 204. So further, NVIDIA claimed that this logic is capable to upscale the low resolution image from 1080p to 4K resolution. By using this invention, the video frames are modified such that they can be displayed at the native resolution of the screen without being stretched. That's all from me today, and I will pass the session back to Mr. Wong.
Yeah, thank you, Kui and Ong, for your explanation. Yeah, I think these are heavy stuff that require engineers' input. So I come back to the other examples. So what you have seen from my 2 colleagues is, what NVIDIA has done is whatever solution, whatever problems that you want to solve, that can be solved using mathematics, even though it can be very, very complicated mathematical processing. NVIDIA can do it. They break it down into series of steps, and they use the parallel processing power of the GPUs to process it concurrently. And they have a CUDA platform to enable the programmer, the researcher, to do the programming quickly and effectively. and that will enable a solution to be launched quickly. So just now what you have seen at the chips level, what NVIDIA have done. What I'm going to do now is to look at the platform level, how NVIDIA protects the various platforms that it has. And one of the example that I can find is the drive platform for autonomous driving. The drive platform is behind the self-driving car of some of the cutting-edge companies like Tesla, right? So I venture to look at a US patent 2019-250258251 entitled System and Method for Safe and Reliable Autonomous Driving, to see how NVIDIA protects the platform that facilitate autonomous driving functionality. In this patent, you can see how NVIDIA has patented a combination of GPU with CPU with some software to provide a faster, reliable, energy efficient system on the chip solution for autonomous driving. And it is a flexible and expandable platform for a wide range of autonomous vehicle. It can be car, it can be buses, it can be aircraft, it can be watercraft. So and this is the patent, right? That talk about the NVIDIA Drive platform. And as you all know, right, autonomous driving is one of the most computationally complex tasks, because you are driving at 100 kilometers per hour. You need to capture so many data at the same time, and the data has to be fed to a computer, a supercomputer that can process all this data, learn this data, store this data, and command the car to react according to the ground situation, right? It's a highly mathematically complex task. But NVIDIA has a solution to it using this system on a chip combination, which they have patented in this particular patent. So this patent comprises of at least one CPU for processing the visualization, minimum one GPU. There are thousands of GPU used to do massive parallel processing, right? Then they have this vision hardware, the ADAS hardware to capture the image. You have a deep learning software to learn, and you have a memory module to store this information and to connect to a system on a chip to and this system on the chip will act as a vehicle controller to control how the car drive autonomously. So this is how, right, a platform is being patented, combining the special purpose chip, the software and the hardware together. And by filing a patent like this, they own a platform, right? They own a platform. And if other car companies want to use this combination for autonomous driving, they get freedom to operate, from NVIDIA. And this patent, in the same patent, the autonomous vehicle itself was also patented, not only the chip but the vehicle. And this claim protects a vehicle, autonomous vehicle, that comprises a powertrain, and the powertrain is connected to system on the chip that actuate the powertrain, that controls the powertrain. And the system on the chip comprises again of CPU for visualization, GPU for multiple parallel processing, computer hardware to capture vision, deep learning to learn about all this data, and the memory to connect with the processor, with the controller. So by doing that, this drive, the vehicle, they are all being captured, being protected using this particular patent. Okay, so now, as we all know, the latest hype, I wouldn't say a hype, the greatest, hottest topic now is ChatGPT generative IP. And NVIDIA is one of the biggest winner in this current red hot generative AI space. In a open AI system, reportedly more than 10,000 chip NVIDIA GPU is used to train the ChatGPT AI, right? So NVIDIA GPU, which was originally created for graphic card for gaming, has turned out to be perfect for running deep learning algorithm. Using CUDA, previously to code a GPU, you need to use low-level machine coding, which is very, very slow and complicated. Using CUDA, researcher can easily code their deep learning model quickly and cheaply on NVIDIA GPU and use it to do AI. That's the reason why NVIDIA was able to capture the opportunity when a new opportunity arises. Okay, so and there are many complicated patterns filed by NVIDIA on the chip, right? But because it's too complicated, I don't want to go too deep into that. I selected some more AI application patent to share with you. And where one of these patents that NVIDIA has protected is they have come up with way, as you know, an AI model, you need a lot of data, right? They are data hungry. They need to learn. They need to have plenty of data. So what NVIDIA has done is they come up with a way to generate synthetic data set to train neural network. So to generate this, they can use this synthetic data set to train specific visual tasks like autonomous driving, facial recognition, and so on. The advantage of having this synthetic data set is you make training more accessible, and also you overcome the privacy issue. There's no privacy issue there. So this is the pattern that protect is a recent patent filed in July 2023 that enable generation of synthetic data set for training neural network. So if you look at the claim, which is the combination owned by NVIDIA, it's very simple. It's only like a two-liner. It is a process, right, where you can use computing using the generative AI machine learning model, and you can feed this generative model, AI model, with scene graph, one or more scene graph. And this generative AI model will generate transform scene graph. And this transform scene graph will update the attribute of the original scene graph. And using this transform scene graph, you generate images representative of that you can use to train the AI model. Yeah, so this is how NVIDIA try using computer, feed them with scene graph, generate modified scene graph that capture some of the original feature of the original scene graph, and using that to generate images to train the computer. And this is what NVIDIA has claimed. And the other application patent that NVIDIA has come up with is a chat box for all season. And in this chat box, in short, it has two, inside the chat box, it has a closed domain chat box that is very specialized, understand only certain topic. It is a closed one. An open chat box where it knows general knowledge. You have a specialist chat box and a generalist chat box together. And this AI platform combined these two, and it used an intelligent dialogue management system to manage. And they will, whatever input you give to this chat box, be it a visual or it can be a speech or a texture input, then the intelligent dialogue management system will see whether it's general. If it's general, it give it to the generalist chat box to answer. If it's a specialist question, then it will give to the specialist chat box to answer. And by doing that, by protecting that, you know, they come up with a general cum specialist chat box. And again, this is patented in a very recent patent, April 2023 patent, that capture this combination, right? And this is basically what is claimed by NVIDIA. It has a processor. Processor has this circuitry, and you determine the inquiry, whether it's for open or is it for closed chat box. So it was sent to this dialogue management system, will send it to the dialogue system specialist or generalist, and they will give output back to the queries to the user. So this is how this chat box for all seasons are being protected. And as you know, NVIDIA is one of the hottest stocks today this year because of the AI craze. The stock price of NVIDIA has more than tripled, 300% growth in 2023 alone. And this is making it one of the trillion-dollar company, right? One of the few companies that has vaulted past the $1 trillion market cap. And if you are an early investor in NVIDIA 20 years ago, you put 1,000 in the stocks, it will be worth 333,000 today, a 333 times increase over the space of 20 years. So this explains how successful the company has been, and how in today's seminar, we have shared, right, how NVIDIA use patent to protect some of its winning formula.